Welcome back to my channel. Today we are asked to solve for sine 3 theta, of which we have been given sine theta equals to 1/3, and we are asked not to use a calculator. So in this way, what should come into our mind is that we are asked to expand sine 3 theta before we be able to go into solving today's question. For us to expand the sine 3 theta, we have to look into the double angle formula, and also we have to borrow from Pythagoras theorem. We're going to look at these 2 or 3 formulas together and see how we can put them together and solve this question. The first thing is to expand sine 2 theta, because we are going to need it. To expand sine 2 theta is going to be like sine theta plus theta, and this is going to give us 2 sine theta cos theta. But how do we get that? How we get that is that we're going to have sine theta cos theta plus cos theta sine theta. So if you have this together, because they have the same together, so we're going to have 2 sine theta cos theta. So that is an expansion for sine 2 theta. Can we look into the cos 2 theta? If we look into the cos 2 theta is going to give us the same way we did sine 2 theta. By expanding it, we're going to have cos into theta plus theta, because it's a double angle. So if we expand this is going to be a little bit different from sine 2 theta. What do we see there? You're going to come with cos, then you come with sine, and this sine, the plus sign changes to minus sine. So in that way, we have cos theta minus sine theta sine theta. We can see the difference from the 2 expansion. Cos theta minus sine theta sine theta. So if you multiply cos theta and cos theta, you're going to have cos squared theta minus sine squared theta. I hope we are following that. But in this expansion, we really need the sine, not the cos. So we should find every possible means of turning the cos into sine. And if we do that, we can remember our Pythagoras theorem under the trig says that if we have cos squared theta plus sine squared theta, that will give us 1. So from here, we can convert cos squared theta. So cos squared theta will now be equals to 1 minus sine squared theta. I can then put cos squared theta, represent my cos squared theta as 1 minus sine squared theta under here. And if we do that, that means cos 2 theta is going to give, instead of writing out cos squared theta, I'm going to write 1 minus sine squared theta. And already I have minus sine squared theta here. So minus sine squared theta. So in that way, it means that the expansion of cos squared theta will give 1 minus 2 sine squared theta. We can also relate it in case of cos theta, but we really need sine theta to be expanded. That's why we should look into a way of making the cos back into the sine, and that is what we have gotten. Now, if we are now looking at sine 3 theta for the expansion of sine 3 theta is the same thing by saying sine into bracket 2 theta plus theta. How are we following that? Sine 2 theta plus theta. And if we expand that, what are we going to have? In that way, we're going to have that. In that way, we are going to have that. We are going to have, let me write that out, that if we have sine 3 theta is the same thing as sine 2 theta plus theta. So if we expand that, based on the fact, the way we expanded the sine 2 theta, that gives sine theta cos theta plus cos theta sine theta. So the same way we're going to expand this, and it's going to give us, this is going to give us sine theta, let me say sine 2 theta cos theta plus cos 2 theta sine theta. I'm pretty sure we are following that. So this is where we need the sine 2 theta and the cos 2 theta we have expanded in the first place. And we know that sine 2 theta is going to give us 2 sine theta cos theta. So I'm going to fix that in there. So this is going to give us 2 sine theta cos theta. And I'm going to put this into bracket cos theta. So plus cos 2 theta is going to give us 1 minus 2 sine squared theta. I'm going to put that in bracket all into sine theta. I think it's making sense now. So if we have to expand this, so we're going to have, if we expand this, we're going to have 2 sine theta cos squared theta. 2 sine theta cos squared theta plus, I'm going to use this sine theta to expand this one in the bracket here. So I'm going to have sine theta times 1 we give us sine theta, and if we use this to expand 2 sine squared theta, that will give us 2 sine squared 3 theta. How we're following that? So we can expand further, and if we expand further, that means that we don't want this cos squared theta to be here because we need sine theta. But the cos there, we have to find a way of removing that, of which from also the Pythagoras theorem that says that cos squared theta plus sine squared theta equals to 1 minus is equal to 1. So from there we'll be able to find that cos squared theta equals to 1 minus sine squared theta. We're going to fix that in there also. And if we do that, that means we're going to have 2 sine theta into bracket 1 minus sine theta, 1 minus sine squared theta, 1 minus sine squared theta, 2 sine theta into bracket 1 minus sine squared theta plus sine theta minus 2 sine cube theta. Fine. So we can then expand this. And if we do the expansion, we're going to have 2 sine theta minus 3 sine minus 2 sine squared theta plus sine theta minus 2 sine cube theta. This is going to be, this is going to be 2 sine theta minus 2 sine cube theta, minus 2 sine cube theta. So if we now add this together, so we're going to have this one and this one, we give 3 sine theta, and this we give minus 4 sine cube theta. That means that sine 3 theta will give us this. Sine 3 theta is going to give us 3 sine theta minus 4 sine cube theta. And we already know that sine theta, equals to 1 over 3. That is given. We're given this. So we just need to say now that sine 3 theta is just going to be 3 sine theta minus 4 sine cube theta. It's pretty easy now. So that means that we have 3 times sine theta, which is 1 over 3, minus 4 times sine cube theta is the same thing as saying 1 over 3 cube. That's the meaning of that. So in that way, this is just going to give us 3 here, 3. We have 1 minus, this is going to be 4 into bracket 1 raised to the power 3 divided by 3 raised to the power 3. Fine. And this is going to give us 1 minus 4 times 1 over 27, because 3 raised to the power 3 is going to give us 27. 3 into 3 places. 3 times 3 times 3, 27. So we have this now as 1 minus 4 over 27. We can find the LCM, and if you find the LCM is going to be 27. So we go this way. 27 times 1, we give 27, minus 4, we give 23. 23. So the answer is going to be 23 over 27. I'm pretty sure we know how we got this done. If you're looking at the LCM, is going to be 27, and take this one as 1 over 1. 1 in 27 will give you 1. We give you 27. 27 times 1, that is 27, minus 27 in 27, we give 1. 1 times 4, we give 4. So this is how we got 27 minus 4 to give 23 over 4. And thank you very much for watching my video. Please kindly subscribe to my channel. Thank you.